So picking up where we left off on Friday, we had created these two equations for the baby orangutan's, an equation to represent his weight growth over time and an equation to represent his length or height over time. So we look at problem B now that we have those two equations written, and it says how much will the orangutan weigh? Well, that's W on his 6th birthday. And so that represents what? That's his age, so that we're representing age with T. And so do we have enough information based upon the data that we've gathered, the relationship of 20 pounds every 3 years, plus 10 pounds starting, to find how much he weighs on his 6th birthday? Yeah, we just write the equation and we replace T with 6. So 20/3 times 6 plus 10, and we get, we could cancel that, 20 times 2, that's 40 plus 10, that's 50. Okay, so let me be really clear about my expectation of how you answer word problems in pre-calculus. I expect you to at least label the answer and give me a phrase. So I would say he's 50 pounds on his 6th birthday. And that's acceptable because it says how much did he weigh on his 6th birthday? 50 pounds on his 6th birthday. It doesn't have to be a complete sentence. I do expect you to label the answer since it's in pounds. I expect that. So if you don't do that on a test, even if your answer is right, if it's not labeled, I'm going to deduct 1/4 point because you're not being careful and you're not answering the question that you've been asked. Okay? All right. So there we go. Let's go to part C. At what age? What are we looking for this time? So that's T, right? At what age? Time is what? Will he be when he is 48? That doesn't, at what age will the he be? How about let's erase the. Will he be, at what age will he be 48 inches tall? Okay, boy, that was really messing with me. What does 48 inches represent? His length is 48, right? And so we wouldn't be using his weight to age equation. We'd be using his length to age equation. And I'm going to do a little erasing here of our old problem so I have some room. Okay, and so we're just distributing, or not substituting, excuse me, the information into our length equation. So that would be 48 is equal to 6 times T plus 19, because he's growing 6 inches in 1 year. So how many years does it take him to get to 48? He started out at 0 years at 19 inches long, and he's growing 6 inches a year. So we would solve that for T. So I think 29 equals 6T. And then, so T equals 29/6, which you would never answer the question, well, he's 29/6 years old. You would change that. I would like to see you change it into years and months. So I'm thinking, could I convert this 29 inches over 6 into 12 months? Could I do times 2 times 2 and get 12 months in the denominator? Because this is representative of how many months? So 29 times 2 is 58. And that gives us 4 years and 10 months old. So that's an exact answer. I would accept 4.83 repeating years old, but I like 4 years and 10 months better, but you don't have to do that. Okay, so he will be 4.5 years old, or not 4.5, 4.83 years old. Make sure that you label the answer. I'm not labeling it. I need you to label it. He will be 4 years and 10 months. Okay? Goodness. All right. So there's that one. Last question. We'll have 2 more questions to ask in regards to this. Then the next question says, what is the monthly increase? Monthly increase in height of the orangutan. So this is your slope. We know what his yearly increase is. What was his yearly increase? Okay, we're talking about height, not weight. So it's 6 inches per 1 year. That's what that represents, because remember your slope was change in height over change in time. Okay, so he's growing 6 inches a year. And what you're trying to find is how much is he growing per month? So a couple things you could do. You can convert this to, we want 1 month, right? And 1 month is 1/12 of a year. Do you agree? So we could multiply that times 1/12. And that's just basically 1 year equals 12 months. And I'm writing it as a proportion. So one way we could go about this, and I like to do this because these are like physics conversions. When you're doing physics problems, you're always having to convert from one unit to another. If you'll set it up so that you can cross cancel the unit year, because we don't want 6 inches per year, we want to know how many inches per month. Now we can do 6 inches in 12 months. I can cross simplify that to 2 and cross simplify that to 1. And so that's 1/2 inch per month, a 1/2 inch per month. So, and that probably makes sense, right? If he's going 6 inches a year, he's growing 1 inch every 2 months, so a 1/2 inch every month. Okay, so little conversions, and that'll happen today in your assignment too, where you'll have to convert from months to days or things like that. So that'll give you a little indicator of what you're supposed to do there. All right, last thing I want to talk about is this right here. So let's read the problem. It says, sketch on a TL plane a graph that shows the relationship between length, which is your height, right, and time for the first 6 years. So we're still talking about the orangutan. We're still talking about L is equal to 6t plus 19, because that's what we're graphing here. And we're graphing it for the first 6 years. So that means that our time is what it's saying, years. Our time must be between, including 0 all the way to 6, not outside of that time span. I would like you to write down that compound inequality, because you will see it today in your assignment. Understand that you are limited. When you graph the information, you are limited to just those years. Okay, so what the heck is a TL plane? Typically, these are XY planes, not TL planes. So what does the time represent, our X or our Y? X. So I'm going to come over here, and here's my expectation that you do the same thing. You're going to label this T and label your Y-axis as an L. And not only do I expect you to do that, I expect you to tell me, what does the time represent and in what unit of time? What does the L represent and in what unit of L? So what are we measuring? The time is being measured in what? Years, right? But time, we defined it back in when we looked at the problem. Remember? Time is representing age. So down here, when we go to label this, we're going to say age in years, because T is representing his age, and we're measuring his age in a unit of a year. Okay? And what does the length or the L represent? His length in what unit of measure? Yeah, length in inches. So I do expect that you actually not only label TL, but you give a brief description of what the t-axis and the l-axis stand for. Leave no room for ambiguity. Did you hear me? Be clear. I will be grading you on your ability to create a precise, useful graph of data. And that includes labeling clearly what your axes stand for. Also, I expect you to title your graph. So we're about to graph what information, what could be a good title for this graph. What are we measuring? Of what's the subject of our problem here? It's an orangutan, right? And what are we measuring here? What are we graphing? His height. Could we just say of a young orangutan since it's only the first 6 years? And of course you might come up with something a little different. You might edit that and come up with a better title. I need you to understand that I expect all of those things to occur and for you to be thoughtful and clear, no ambiguity at all. Okay, so now let's go talk about our information. We've got to figure out, this is a linear relationship, okay, with a slope of 6/1, and our change in x is 6. So when our time was 0, how tall was he? 19. And in the first year, he grew 6 inches too. And in the next year, he grew 6 inches too. And then 49, 55. It was a constant change. This is a really good indicator right here that this is a linear representation because it's an arithmetic sequence. It's a constant change. It's not changing. And the year is changing up 1, up 1, up 1, up 1. This is a really strong indicator that we're talking about a linear relationship. So when we graph these, they should graph a line. Okay, so we've gathered all our data. Now we're going to go and think about how we're going to put a scale on each of these axes. So on our time scale, we're starting at 0, and we're going to what? Do we need to go past 6? No. So how do I want to break up my scale? In years? In half years? What do we want to do? Years, right? That's what we did. So I would see the half of that's 3. So I'm going to go about halfway. And I'm not looking for perfection here. I'm just looking for no ambiguity. So 3 there. So 1, 2. I hear my phone ringing. All right. So I'm looking for that scale to be useful and somewhat evenly separated. Now let's talk about the scale that we're going to put on our height or our length. You think 5? What should I stop at? If I'm stopping at 55, would it be good to go just up to 60 and stop? And should I go by 10s or what? 5s, 10s, what do you want to do? 5s, okay. So if I make this 60 up here and I make this 30 right here, I think first what I'll do is I'll break it into 10. So 10, 20, 30, 40, 50. And then I can just go back and cut those in half with little half marks maybe. I mean, that might be helpful to have those little in-betweener points because a lot of these points aren't ending, none of them end on the 10s, right? And then maybe don't, you could just put the 10s and not put 15 and actually write the numbers, but have the tick marks there. I think that would be really good. So that was a really beautiful graph. Now all we have to do is plot our data. So at 0 years, he was 19 inches. I'm going to go change the color here. Purple graph. All right, 19 inches. And at 1 year, he was 25 inches. And at 2 years, he was 31 inches. And at 3 years, he was 37. And at 4 years, he was 43. 5 years, excuse me, 49. And at 6 years, 55. Anyway, my graph's not totally beautiful, but it's good enough to show that linear relationship and all of the time in between. So it would actually fill in all the space here, connect all your points, but I would not go past 6 because it asks for the first 6 years, not 6 years in one day, just 6 years. So don't continue with an arrow off forever, because I doubt that he is going to continue to grow 6 inches per year until he dies. That'd be like going, okay, Mrs. Frame, you're 45 and you grow 6 inches a year. Look, guess how tall I'd be? Like, nobody could beat me at basketball if I was that tall. Actually, probably could. You could play keep away. Anyway, so there you go. So, your homework, just so we're really clear, I would like you to know how to do your homework, because this is a set of word problems and it's not a worksheet that has room to work. So my expectation is on your own piece of paper, we need to be really clear for everybody, that you're going to be doing 50 to 58 even, but I need you to save this right hand 1/4 of the paper for any corrections that you need to make. So you need to do all your work on the left 3/4 of the page and save the right side for any corrections that are necessary. Again, you can do anything 51 to 57. You can pick 2 odds to do for extra credit. This is due tomorrow. Okay, so you have the rest of the period to work on that.